Okay, so in this video, we're going to look at product functions. These are closely related to the idea of a sum function, addition of ordinates that we did in a previous video. Go check that one out. But this time, instead of adding the y ordinates, we will multiply the y ordinates together. Now, again, we only use this on functions where we know the individual ones, but we don't know what it looks like together. So x sine x, for example. I know what x is, I know what sine x is. Together, multiply it, I don't know what it looks like. And same with x squared log e of x. I know both of those individually, but together I don't know. Now the concept's the same idea. You're multiplying y values instead of adding them. But the hard part is number properties. You need to remember number properties when you're doing this stuff. So you need to remember things like the ones that we always know, that if you're multiplying two positives, you get a positive. If you multiply a negative and a positive, you get a negative, and so forth. But the one that gets forgotten a lot is what happens when you multiply numbers in their size. So if I have a number b, it doesn't matter what b is. If I multiply it by a number between 0 and 1, the value of b decreases. So the final result will be less than b. It'll get smaller. So if I have 1/2 times b, I'm really saying half of b. So a number between 0 and 1, when multiplying, will reduce the other number, whatever the value of b is. But if I have two values, if I have a value of b that's bigger than 1, it'll increase b. So the final result will be less than, so bigger than b. Okay, so you're multiplying between 0 and 1, the number diminishes. If you're multiplying by a number bigger than 1, it increases. And that is really important when you're doing this, to get a general idea of how far something's going up, something's going down. It's not going to be an exact science. It's going to be an approximation, but it gives you an idea what happens. And remember, of course, that if you're multiplying two functions together, the domain of the final result is going to be the intersection of the individual domains. So in this one here, you got y equals x. You have all real values for that thing. Y equals log of x. That is x is bigger than 0. So together, the resulting domain is x is bigger than 0. So let's do this one. I'm going to multiply them together. I'm going to have a look at what happens when I am multiplying this together. So I'm going to draw this log function first. It has an x-intercept of 0. We know that. And at about approximately there, it's going to be at 1. So it's going to come through something like that, fairly sharply out. That's what a log graph looks like. I knew that was about 1 here because log base e of e is going to be 1, and e is approximately 2.8, which is about there. Let's look at y equals x. Now y equals x, I'm going to draw it like this. I can extend it further down this way as well. I'm not so worried about that end because I'm only going to be having this bit up here as a result. Now I'm multiplying them together. Now a real key point is to look at x-intercepts, because one of them is 0 at that point. The y value is 0, which means if I multiply them together, you get 0. So if I multiply this y value and this y value here, you get 0 because it's going to go through that point there. Notice everything to the right are positive numbers, so multiplying those will give you positive results. Everything to the left, one is positive, one is negative, so multiplying those will give you negative results. So the left-hand part of the graph is going to be down here, the right-hand part of the graph is up here somewhere, or even up here. So let's do the left-hand part first. Let's multiply this one here and this one here. Now this y value is almost 1. So if I multiply something by 1, nothing changes. But if I multiply by 0.8 or 0.9, it does change, but doesn't decrease much. So what's going to happen is the final result over here is not going to so much be really decreased, but just maybe a little bit decreased, something like that there. By the time I get to the middle here, let's say 0.5, it's going to approximately halve that, which is going to be, I guess, there-ish, because 0.5 times that y value is about half. But then notice this red one goes towards 0. Now I know at 0, anything times 0 is 0. So I'm going to put a 0 there, but it has to be an open circle because the domain was bigger than 0. But as this value is going towards 0, this one's going off towards infinity, but 0 wins out. multiplying by 0 wins out. So what's going to happen is, as this number gets smaller and smaller for y, the result is going to get closer and closer to 0. So you're going to end up with some kind of little turning point looking something like that. It's not going to be perfectly symmetrical, and you're only going to be able to get a general idea of what's happening, not an exact idea. Okay, let's continue on the right-hand side. On the right-hand side, we said if you multiply by a number bigger than 1, it increases. So let's have a look at a section, this first section here. All the y values are there are between 0 and 1, aren't they? Because we can set up the scale of the graph, which means anytime I multiply this red value, all the red y values, by the yellow ones, it must decrease because these are all less than 1. And it's not until I get to this point here that it starts to increase in size. All right, so this one is almost at 1. So you multiply the red one, it's going to be almost at the red one. This one's about halfway. So multiply this one, it'll be approximately halfway. So that goes something through there. And then once you get past this point, that number is bigger than 1, that number is bigger than 1. Multiplying those is going to increase all the time. So you get points above all the way up now. Now, of course, as this yellow one gets bigger, the multiplication will become larger and it'll get further and further above the red graph. It's going to look something like that. It's a bit disjointed the way I've drawn it, but it's going to look, let's try with a different color, maybe at the top. It's going to hopefully look something in the lines of something like that. Like I said before, the depth is going to be an approximation, not an exact. So just do the best you can to keep it as tidy as you can. Let's do one more example. We have x sine x. Once again, let's draw the individual one. So let's draw x by itself. And this is all real values as its domain. Let's look at sine x by itself. It has also got a domain of all real values, so the final domain will be all real values. Let's draw a sine graph. There's your sine graph there. Probably the best one I've ever drawn. And so that I don't wreck it, let's copy and paste it down here. Bit dodgy, but gonna save some time. And y equals x, we know, is going to go through something like that, extend. And the way I'm drawing, of course, I'm assuming all these are 1 each as in going along. But I can't do that, of course, because I have sine, so it's going to be a little bit off. I should take that back. Sorry, this is about 1.57, so it's going to go through about there and there. Sorry. Going to fix that, make sure I get the scales right, otherwise it'll be completely off. Okay, now for, I guess, simpleness sake, let's just deal with this right-hand side, but you could go to the left-hand side as well. We want to look for x-intercepts x-intercepts first again, because that gives me when you have y equals 0 and multiplying 0 by anything gives you 0. So let's look at it. At this point, they're both at 0, so multiplying them together will give you 0. At this point, that one's 0, so doing this one times this one will give me a point of 0 there. If this continues on, doesn't matter what it is, there's 0 there, so that one times that one will give you 0. That's your first bit. Next bit is this yellow graph is all positive here. So everything up to there, multiplying the two together gives me a positive result. Everything afterwards in that section gives me a negative result. So let's see what happens. We also know the yellow is between 0 and 1. That's between 0 and 1, which means when I multiply them, the red one will decrease in size. With the exception of that point there, because that is where it is 1. So when y equals 1, you multiply the red one, it'll stay there. Okay, so it's going to look something along the lines of, well, these two things are less than 1, so it looks something along the lines of that. And then it's going to start coming back down because this number here is less than 1, which is going to decrease this when I multiply them. So come back down And it's going to come back through there. This one here gets close to 0, so overpowers that one quite quickly and squashes it. Then down here, we have 4 there, and that's -1. It won't be exactly 4, but it's going to be approximately. But then -1 times this, it's just going to reflect this point directly down here-ish. Here, sorry, it's going to be about there, just above the -4. So I have to join these points somehow, and that's going to be just a smooth line coming down here. And then notice this starts to decrease, goes back towards 0, which means this graph has to continue back up towards 0, and it would continue going past and getting larger and larger every time as x gets larger and larger every time. Now, the same is going to happen this other way. If I was going to continue it, they're both negative numbers, so it's going to give me a positive result. So it's going to go up and do the same sort of idea as we have on the right-hand side. And that is product functions. But remember, you only need to worry about a general approximation rather than a specific exact result.